Welcome and hello. This is a video tutorial in HEC ResSim, and in this lesson, we're going to be talking about Monte Carlo analysis. Monte Carlo analysis is an alternative type in ResSim that enables the user to evaluate the impacts of simulation results due to the uncertainty of model input data. All right, so we're going to explore what that means. On the screen here, we have a reservoir network, and I'm in the simulation module. I've already ran a simulation with a base alternative and then a couple trials for standard and Monte Carlo. I'm going to run the standard simulation first and then show you the results and then show you what I plan to do in the Monte Carlo analysis. In this reservoir here, we have a guide curve elevation of 1480. The inflow here in the bottom plot is in black, and it kind of varies between 1500 and 4500. And then the release is in green with a minimum release of 3000 CFS. So you can see that as the flow's inflow is less than the minimum release there, we get a drop in the water surface elevation in the reservoir pool. What I want to do in this Monte Carlo simulation is modify this minimum release. Instead of making it 3000, maybe drop it down, maybe increase it, and see how that affects the minimum water surface elevation in the reservoir. So we're going to run a bunch of iterations, look at a bunch of results using statistics and plots and tables. I'll make this one active and then edit. Let's go ahead and select alternative editor. First thing to do is in the run control tab, if you're running a Monte Carlo analysis, is to select Monte Carlo right here in the radio button. The user's manual actually makes mention that it's easy to run a standard simulation first, simulation with a standard alternative, and then to, after that, make a copy and create a Monte Carlo simulation. So you have sort of a base case up and running. Okay, other than that, we can leave the other standard tabs that we typically create in the alternative the same as the standard alternative, and then head over to this Monte Carlo tab. This is where I'm going to be discussing most of this lesson. What we have in the top is three subtabs: input variables, output variables, and MC controls. So I've already actually inputted some data, but we can do it again so I can kind of talk it through. If you have a record you want to delete, select it and then click this remove button. This is the input variables subtab. This is where us as modelers will add input variables that will vary, that will depend on the iteration and the statistics. So in the case of that minimum release, it doesn't always have to be 3000. It could be, like I said, a range of different numbers, and then we could investigate and analyze how that water surface elevation responds. Let's go ahead and do that. I'm going to click the add button over here. And then what I'm seeing is a wizard, step 1 of 4, and the instructions are at the top here. So the first instruction for step 1 here is select the variable type. On the left, I have a bunch of options: time series multiplier, input time series, reservoir rule parameter, look back value, rating curve, and script. So I have to select one and only one. And then on the right, I have uncertainty type as well. So whatever you select for your random variable type, and I think these are pretty straightforward, that will actually affect some of the later steps in this random variable wizard. So for instance, if I said time series multiplier, right now my only time series is up at the upstream junction where I have an inflow and it's just a value of 1. But if I click next, then it's asking me to select the location of the parameter and it's a global value of 1. So I'll click next. And then this is selecting a variable parameter modality. I'll talk about that in just a moment. And then if I click next, now I'm expected to specify the distribution of that value, which was 1. And but it won't always be 1 because now I'm going to be running multiple simulations or iterations using this Monte Carlo analysis. The default distribution is gamma, but I can select triangular, empirical, and then uniform. Whichever I select, I then have to specify the parameter data. So discrete would be if I'm just typing in values and probabilities. Gamma, you can go with the shape and then the scale. And if I change some of these numbers, you'll see the plot over on the side update. We have a PDF plot here on the right, and then a CDF below that. let's see what else. Empirical. So that's based on exceedance probability. We have log normal. This actually makes sense. Log normal and Gumbel is probably the most common. That should be used for natural phenomenon that can't be negative, such as inflows and normal. And then there's also the log base 10 normal. Okay, so let's go ahead and just make something up here. Okay, so we'll just go with gamma, sure. After we've set these numbers here, we can also specify the distribution clipping. So if we wanted to specify a minimum and a maximum, then we can do that here. The first one is minimum. So if I'm looking at this plot over here, and I see it ranges from about 0.25 up to about 4.25, but I really only wanted it to range from say 0.5 to 2, then I could say 0.5 in the minimum and then tab off of that. And then over here, I could say 2.0 and tab off of that. Now what I see the plots have updated because 8% was actually less than zero point 0.5 and 24% was actually more than zero point 0.2. So that, 32% has been reallocated to the range here. And that's why this red line, which excludes what's been cropped off, is at a higher probability than the blue line, which is the original without any cropping. Okay. And that same relationship occurs here in the CDF as well. Okay, so I'm going to not do that. Let me go back and show a couple other examples. So for input time series with Monte Carlo, alternative type, I could have multiple different inflows. So I would select the input time series and then next. And then at this point, I would have to specify not a statistical distribution, but I would actually go ahead and select a record, navigate to that time series inflow, select it, and then come back and specify a weight, referring to like the weight or the probability, what's converted to a probability that that particular inflow would be used in the simulation. That's the second one. That's input time series. I'm not going to do all of these, but the next one I do want to actually use for this example in this lesson is reservoir rule parameter. So if I select reservoir rule parameter, um, this is for that 3000 CFS. That was the constant value. It's already selected. It's the only rule there is in the network. But, this is a table, so you could have tons of rules or tons of time series data. I'll click next. Here we go. So I got a similar screen that we saw previously. I'm going to use a log normal and then go with the linear scale. So instead of 3000, actually, I will keep that as the mean, but then the standard deviation I will say is now actually let's make the mean 2800. The standard deviation is going to be less than 1500 for sure. Let's call it 400. I'll tab off of that, and then let's also set a maximum of how about 3500. So that excludes 5%. Actually, let's say there's no minimum here. Okay, so I'll say finish. All right, so after we've created an input, we now have that input down here in our table. If we want to deactivate it, we can just uncheck this checkbox under the active column. I'm going to actually activate it though. And then if we want to make edits, we have to go ahead and click edit here. And then we're back to the wizard at step 1. And unfortunately, if you click next, nothing happens. So there's really no editing. You have to remove it and then create it again. So nothing's perfect. So I'm not going to remove that, but I do want to point out that there can be correlation here between multiple input variables. I would actually need a second input variable to demonstrate that. Real quick, I'm going to go ahead and add a second input variable. Sure, we'll say it's a time series. Next, this is that 1.0 multiplier. And then sure, we'll use that default distribution. So now we have two input variables. And if I wanted to specify a correlation that's not like two independent variables, there's actually some sort of direct or inverse correlation between the two. I'm going to click correlation, and then I'm going to say new set. The correlations are based on correlation sets. So I'm going to give it a name. I'll say MC correlation set 1. Okay. And now it's asking me to include which input variables are part of this correlation. So there's only two to choose from. I'll just add both of them, click OK. And now what I have is a matrix here. It's a symmetric matrix because it's the transpose is equal to itself, where the diagonal is 1. So it's really a correlation matrix. X1 x2 is the same as x2, x1. So this is the only value I have to type in. So if I typed in a 1 here, that changes this value up here to 1 automatically, and this would be like a perfect correlation. If it's a positive correlation, but not super strong, I may say 0.25. And obviously, it can range from -1 to 1. So a negative correlation that's fairly strong would be like negative 0.78. Or if it's a negative correlation and it's not strong, I could say negative 0.14, something like that. I'll just say 0.25. So it's positive, but it's kind of weak, and then click OK. So the actual compute routine for this Monte Carlo alternative would use that correlation in its computation, and we would also see that correlation data show up in the reports for the output data. But I'm not going to do that. So what I want to do is remove that real quick. I'm going to go to the correlation set and then delete the set. Okay. And then I'm actually going to also delete that input variable, which is right here, and remove. Okay. So that's input variables. If you have a ton of input variables, you can use these filters to find the one that you're looking for. The next tab over is output variables, and I've already been messing around here, so let me just remove this one, pretend it wasn't there. This is the blank screen. If we want to add an output variable, we click add. Now, for this particular situation, I'm curious about the minimum reservoir elevation in the reservoir pool. So I'll select that particular record I'm interested in, click next, and then what I have on this screen is a few options to specify, am I curious about the maximum, the minimum, or the mean? Some parameters also include volume, I read, but I'm going to go with minimum. Next, I can specify a flag. So if I'm particularly interested in iterations that exceed a certain threshold, then I could click check for the flag. And then maybe I'm interested in the records that are below 1480 is the guide curve, maybe something really low like 1460. I could do that, and then I could look into those results at a later time. Convergence is a checkbox we need to check for at least one of our output variables to specify when convergence has actually been achieved in the compute simulation. So 90% and 10% for the confidence and tolerance is fine. We could probably lower the tolerance a little bit. According to my notes, the confidence there is the percentile interval upon which the convergence is based, and then the tolerance is the maximum percent change in the average of the output statistic necessary to consider the variable converged. Okay, so that's not going to be a problem for our simulation here. The elevation values of interest here also allow us to specify certain elevation values in this case, because I chose pool elevation for the output value, for us to see the percentage of iterations that exceed that particular value. So I'm going to type in some numbers here. I'll say, okay, so that looks good for output. I'll click finish. Now we have an output record added to the table. If I wanted to edit it, I believe I can, yeah, make edits directly in this table, or if I, yeah, there's an edit button over here on the right side as well. I can add more. I can remove any of the listed output variables if I want. But let's move on to the controls. So if I click on this MC controls tab, what I'm seeing here is a few runtime controls. We have the minimum number, typically 100 will probably be fine, and then the maximum number of iterations, and then also a seed number. So the way the minimum works is even if convergence has already been achieved, then the simulation will continue until that minimum number of iterations has been met. So on the minimum side, it's a and condition. So the convergence and the minimum has to be achieved. As for the maximum, if the convergence has already been achieved, like at, I don't know, 300 or 400 or 500 iterations, the simulation will stop. But if the convergence has not been achieved by this maximum number of 1000 iterations, then the simulation will stop anyway, even if it hasn't converged. So that's what this maximum number of iterations field is purposed to do. The last number here is standalone random number seed. And I mean, computers can't create random numbers by themselves. So it's asking the user to just type in some number. So you can, any number between 0 and 1. So let's go with 0.254 this time. and ResSim will use that to generate some of its random numbers. Down on the bottom, the simulation options here continue to add iteration to previous Monte Carlo results. You would select this checkbox or this radio button if you were running the same simulation over and over again in batches and you just wanted to accumulate more and more data. The second radio button says clear previous Monte Carlo results and start first iteration. You would do this if you were actually making changes to the alternative and you wanted to remove the previous records. And then simulate and save results for iteration. This allows the user to specify certain iterations that they may want to rerun and analyze more in depth in the case of sort of an extreme case that has been flagged. All right, down below that, we have a couple buttons here for pre-sample script, post-sample script. The pre and post-sample script buttons will open up a script editor, which we've seen before in other lessons where sort of like state variables, for instance, where we have a initialization script, main script, and cleanup script that runs before, during, like on each step, and then after the actual compute with API trees and libraries, model variables, and so on over on the left. That's a little beyond the scope of this lesson. This lesson's running a little bit long, and then PostScript is the same. So let's go ahead and run the simulation finally, look at some results, and then call it good. All right, I also need to change this back to the second option, clear previous results before starting iteration, and I'll go ahead and click save. All right, so we are ready to simulate and oops. Oh, all right, so it's running right now, 30, 40, 50, 60. It's going to go up to at least 100. And cool. So it converged. It ran in 7 seconds. That was plenty fast. Now, usually you'd right click and plot to look at results, but for Monte Carlo results, we'll go ahead and go reports, Monte Carlo, and then we have three options here. There's a text output report here as the first option, histograms, and then convergence plots. The first one's the only real report though, so let's go ahead and check that out. What I have on the screen is a text-based report. We have some basic information about the simulation up top. Then we have the input variables and information about that as well. Again, our input variable is how we're changing that minimum release rule for the entire simulation. And that's so 50% here is right around 3,000. And then like 1% is very small of 2,094. 99% is going to be right up at near our maximum of 3,500. Here's the convergence variables, some output data here. And we see, again, this output data refers to the percentile and the minimum water surface elevation in the reservoir. And then we don't have any correlation sets down here, but here are the different elevations that I define as well, from 1470 to 1480 by every 2 feet. So 33.5% of the time, we actually had a simulation whose lowest water surface elevation was below 1470 based on our Monte Carlo inputs and everything else in the network. Okay, if I go reports, Monte Carlo, and then histograms, what we're seeing here is the purple is the actual data that was used in the simulation. And then red is this line here is the continuous, what you might call theoretical distribution of minimum flows, minimum release rule for that reservoir. And then here's some of the data down below. All right. And then the last plot to show is our report is this convergence report. So at the top, we see our reservoir elevation, and this is for each realization it's called, but these are just iterations from 0 all the way up to 100. And then the bottom plot here is the air. So there's really no air. I specified a tolerance of 1%, but that's way up here. So there's no problem with convergence. And then the middle plot here shows the elevation. So there's like a running average and then green is lower tolerance and then upper tolerance and then some estimated air values in between. Okay, so that was a lot for the one lesson, but there's a lot to say about Monte Carlo simulations, and I feel like I was just scratching the surface, but using some example as well as the description, go ahead and check out the user's manual as well in Appendix H. Monte Carlo alternative in ResSim is a powerful tool that can help us get a lot of results with just a little bit of work.